everyone. Today's notes are on section 6.3 and 6.4. So we'll start with 6.3. The triangle proportionality theorem and its converse are both talking about triangles that have a parallel line that goes through the middle of them. The theorem says if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So here in the picture, the blue over the purple would be the same thing as the blue over the purple. And then also the blue over the green would be the same thing as the blue over the green. And so you can see how you can set up those proportions right there on the side. Remember that proportions are solved like equations. The converse of the triangle proportionality theorem basically says the opposite. So if a line divides two sides of a triangle proportionally, then that line is parallel to the third side. So if blue over purple was equal to blue over purple, then you know that the line segment from E to F is going to be parallel to the line segment from B to C. So the first part of the notes, we're going to practice setting up and solving some proportions. Number one says find the length of each segment. On this one, they want me to figure out from P to N. That's what's labeled X on the picture right there. The parallel markings are missing from this picture, so go on ahead and draw them in red. PM over MQ is equal to PN over NR. So blue over purple equals blue over purple. And I've color-coded the rest of the notes like that too, so you can see how the numbers match up. We multiply our cross products. So 15 times 6 gives me 90, and then 5 times x gives me 5x. I set those cross products equal to each other because that's how I solve a proportion, and then I divide both sides. So for this one, I would get x equals 18, and x is the length of segment PN, so that's our answer for this question. On this next one, I'm being asked to find the length of segment PN, so I've labeled that x on the picture. That wasn't missing. You need to know to put x there. And so same thing for this one, blue over purple equals blue over purple. You can do that because you know the two line segments are parallel to one another. You multiply the cross product, so 2 times x gives me 2x, 3 times 5 gives me 15, and then divide. So for this one, I would get that the length of segment PN is equal to 7.5. Similarly, on this next one, blue over purple equals blue over purple. You're seeing the pattern there. Multiply your cross products. Grab a calculator for this one because the numbers get a little bit big, okay? So 32 times x is 32x, and then 24 times 40 gives me 960. Divide both sides. So for this one, I get x equals 30. So the length of segment DG is equal to 30. This one's different. So for this one, you're trying to solve to figure out the length of segment MR, but see on the bottom of the picture how the 16 is the whole side. So we're going to use the second set of proportions for this one. So we're going to do blue over green. Where I've labeled 13 on the picture is because that whole top segment from M to P is 13. So blue over green equals blue over green. You'll multiply your cross product, so 13 times x, and then 8 times 16, and then divide. You can write your answer for this one as a fraction or as a decimal. The decimal is an approximation, though it's rounded. So I went ahead and on the answer line for this one, I put the answer as a fraction. And then for the last one in this section, same thing, I'm trying to solve to figure out the length of segment CA, so that's the whole bottom side of the big triangle. And so when I do this one, I'm going to do blue over green equals blue over green. Again, to get the 13, I added together the 9 and the 4. So 9 over 13 equals 10 over x. We'll multiply our cross product and then divide. And so for this one, 130 over 9 is a great way to write the answer to the question, but you could write it as a decimal as well if you preferred. The second set of questions in the notes for 6.3 have us practicing the converse of the triangle proportionality theorem. So for this one, we're not trying to solve for a missing side. We're trying to say whether segment MN and segment KL are parallel to one another. So I'm still going to do blue over purple, but I'm going to do it a little bit differently. This one I'm going to do blue over purple, so 42 over 21. When I divide those, I get 2. And then I'm going to check the other set of values, so 30 over 15. When I divide those, I get 2. And since 2 equals 2, that means that the cross products are equal to one another. So you can conclude that for this one, segment MN is parallel to segment KL because the cross products of the proportions are equal to one another. All right, same thing on this one. You're trying to prove if segment DE and segment AB are parallel to one another. So on this one, I'll do blue over green and then blue over green. But I'm not solving for a missing number. I'm trying to see if the cross products are equal to one another. So blue over green, so 20 over 36. You could divide that and get a decimal. Or here I reduced it, so they both divide by 4, so you'd turn it into 5 over 9. And then when I divide the other set, 15 over 27, that also simplifies to 5 over 9. And again, you could write those as decimals as well. And because the cross products are equal, you can conclude that segment DE is parallel to segment AB by the converse of the triangle proportionality theorem. All right, and the last one on this page, I do blue over purple, so 90 over 72. Those both divide by 16, so it turns into 5 over 4. Again, you could do it as a decimal as well. And then when I do 67 over 54, I don't get 5 over 4. I get a different decimal if I were to write it out as a decimal. And so because the cross products are not equal to each other, we conclude that segment TU is not parallel to segment RS. So in order for the answer to be a yes, the cross products would have to be equal to one another. Moving on to section 6.4, this section of the notes talks about using proportional relationships. The first vocabulary word here to go over is dilation. A dilation means that you have the same shape, but it's a different size. So it's either been made bigger, or in this example, it's been shrunken down and made smaller. The center of dilation is the point where the image is made from. And then the scale factor, this is important. It's the ratio of the corresponding sides. But here it tells you that it's the image over the original. And so the image is the place where it ends up. It's like the finished product, and the original is where it starts. So when you're figuring out what the scale factor is, it's going to be the image over the original. And you can write scale factor as either a fraction or you can write it as a decimal. So here's an example where we can practice that. It says triangle A prime, B prime, C prime is a dilation of triangle ABC, and they want us to find these different measurements for the sides. So down here on the picture, A prime, B prime, C prime, that's the bigger triangle. And so A prime, B prime, C prime, that's the image. That's where it finishes. Triangle ABC, that's the smaller one down there. That's the original triangle. You can just count the lines on the picture. So to find the scale factor, I'll take the green and divide it by the purple. And you got to match up the sides. It doesn't matter which ones you match up. So green divided by purple on the corresponding side. 6/2 is the same thing as 9/3. When you divide those, you get 3. So the scale factor here is 3. The center of dilation is the origin. It's the point 0, 0. And so in this dilation, the shape is getting larger. All right, for this one, for number 2, it wants us to find the scale factor, triangle LMN to triangle GHJ. So the first one's the original, and then the second one's the image. So we want to match up our sides. Remember, it's always, when you find scale factor, it's always image divided by original. So that's why on this one, the 8 goes in the top and the 12 goes in the bottom. So GH is 8 and LM is 12. The bigger triangle is becoming the smaller triangle. And so we're going to do image over original. So 8/12 simplifies to give me 2/3. So the scale factor for this would be a 2/3 scale factor. All right, when we say that two shapes are similar, there are two properties about them that are true. So the corresponding angles of similar figures are congruent. That's one thing. So in this picture, angle A is the same thing as angle X. Angle B is congruent to angle Y, and angle C is congruent to angle Z. And I've just gone through and added some color coding here. I think it's helpful to point out that the order of the angles that match up in each of the triangles where they're stated right there, where it says triangle ABC is similar to triangle XYZ. So the A matches up with the X, the B matches up with the Y, and the C matches up with the Z. So the order of the letters does matter. The second property that's true about similar figures is that the corresponding sides of similar figures are proportional to one another. And so here in the picture, side AB is proportional with side XY in the same proportion as BC is to YZ, and in the same proportion as AC is to XZ. So the lengths of those sides are proportional to one another. Okay, just a little quick review on solving proportions. Remember, when we solve proportions, we're multiplying the cross products together. So you're going to multiply the ones that are diagonal from each other or across from each other. And so 20 times x gives me 20x. 8 times 15 gives me 120. For that first one, I would get x equals 6. On the next one, be careful, you have to do the distributive property. So 12 times x gives me 12x. And then 6 times x plus 4, I would distribute that. That turns into 6x plus 24. Minus the 6x from both sides, and then finish by dividing both sides by 6. So for that one, you would get x equals 4. The reason why we're practicing proportions today is because we can use proportions to solve for values that are missing in similar figures. So here we're being given these two similar figures. We assume they're proportional to one another. A note about proportions, there are different ways that you can set up proportions correctly, but here I'm following the way it was stated in the property. So I'm doing green over green equals blue over blue. So 6 over x minus 2 is going to be equal to 10 over 15. And then I'll multiply my cross products, do the distributive property, and then add the 20 to both sides. You get 10x equals 110. Divide by 10, you get x equals 11. So I can use proportions to solve for missing sides in similar figures. All right, on this next one, we're also going to be using similar figures. It says, in order to find the height of a palm tree, you measure the tree's shadow, and then at the same time of day, you measure the shadow cast by a, it should say pole, as shown, and they want us to find the height of the tree. So same thing. These are similar figures, and so I can set up and solve a proportion. 1.6 over 7.2, so purple over purple, equals 1 over x, so green over green. Divide, and for this one, you get that the height of the tree that I've labeled x here, you could use a different letter like h if you wanted to. It's 4.5 meters. Similarly, on number 6, Brooke wants to find the distance across the stream. And so for this one, I set it up as blue over blue equals purple over purple. So those sides correspond to one another. So d over 35 equals 24 over 42. And then you solve from there. 42d equals 840. Divide both sides by 42. And you get that the distance across the stream is 20 meters. All right, same thing on this one as before. Yahida is 72 inches tall. We're going to set up and solve a proportion to figure out the height of the flagpole. So same thing, green over green equals blue over blue. So 48 over 128 equals 72 over h. And then multiply those cross products together, divide. And for this one, you get that the flagpole is 192 inches tall. And then lastly, this one's also similar to a previous question. We're trying to figure out the distance across a canyon. So we did purple over purple equals blue over blue. 600 over 400 equals 327 over d. And then I multiply my cross products. So 600d equals 130,800. Divide both sides by 600. And so for this one, the distance across the canyon is 218 feet. Again, I can use the properties of similar figures to solve for missing values when I know that two figures are similar.